Hey there, and welcome back to the road to Hannover Messe 2026. We have made a ton of progress with our server, and today I'm going to walk you through the local implementation of computer vision and AI through the use of large language models. Hey there, my name is Christopher Sandoval. I'm a developer relations advocate here at FlowViews. Let's dive into what has been my favorite part of building the server. So part of the story that we're trying to tell with this particular implementation is the fact that you can have both remote and local LLM and AI processing. But that's a pretty complicated thing to get right. You have to manage things like the speed of your response, the accuracy of your response, the latency of the hardware that's processing everything, and then the ultimate user experience. Now, I think we've got a really good balance with this particular implementation, so let me dig in and show you exactly what we have. We're running Ollama as our local LLM solution. Now, it would be a lot more efficient to run something like Llama CPP, but for our case, we want to have both the API LLM functionality as well as functionality for operators who are using the system itself. In other words, I want someone to have the LLM front end, and Ollama is perfect for that. Now, we could build our own front end, but we wouldn't really gain a lot from that process, so we're going to take the overhead hit right now. Here you can see that we have three separate models. We're going to be using Qwen 3.5 for more complex datasets, and then we're going to be using Llama 3.2 as our sort of workhorse model. Now, I do want to note we have a computer vision model installed here, but we're not actually using it quite yet, although that will come into play during later iterations when we add in OCR. So let's start with our computer vision first. We have two Groove Rios that we're using for input and output to simulate our machine centers. And particularly, Rio Unit 1 is going to be driving our computer vision. We're having it generate 4 separate signals: e-stop, running, start, and stop. These are then using FlowFuse's MQTT broker to push out the signals to other instances. Now on the camera server itself, we've subscribed to one of the topics, which is machine start. We have some basic logic implemented here through our switch node. If machine start is true, that is that the machine has been triggered to start, then we're going to push green to our LED. Otherwise, we're going to push red, which just denotes that the machine is not running. Now, in order to do our computer vision work, we're actually calling a snapshot of the image itself. That snapshot then gets stored into local context. We then do a little bit of post-processing on the image and we display it as is as a sort of ad hoc video stream. At the same time, we push the image over to our local ONNX model where we do all of our detection, prepare that for display on our dashboard, and then finally push the image with all of the detections overlaid. In addition to the computer vision piece of this, we also have an Anthropic chat implementation here that allows us to ask questions about the image itself. So here we are looking at the stream in its off state. I'm going to go push the button on the Rio and you'll see exactly what happens. As you can see, we've triggered the process and it's now capturing 1 image per second. On the left side, we have our raw camera feed, and on the right, we have our automatic detections. Now you'll notice that this is doing a lot of detections for things that may not necessarily be true. For instance, it's detecting our platform as sync. This is where the fine-tuning of both the model and the temperature of our detection comes into play. And we're going to be tightening that up over the next couple weeks. Now, not only are we generating this image, we can actually ask questions about it. And the way that this works is like this. We have our user input that is taking the text from our dashboard and is storing that input as a silent flow context. We're then reading that flow context using a send button. This allows us to wait until the question is actually completed before we use the build messages array to send the actual request. And here we're using the HTTP request node to send our Anthropic request, building the request, the URL, and the headers through the build messages array function. After we send that, we save the response that we get back to history before we show it to the user. This allows us to build history over time and give continuity to our interactions with Anthropic. That way we have message context and history throughout the entire conversation. We also have a function here that allows us to interact with Ollama natively. And this is done through our project in and project out flow that allows us to hit an Ollama node locally where Ollama actually lives. Now to tie it all together, we have this instance. This instance is our top-level interaction systems. Here you can see that we have the Anthropic flow that we previously discussed. Then we have the same basic flow, but rebuilt for the Ollama interaction. Specifically, instead of making the Anthropic API call that we have in this flow, we're first preparing our Ollama request and then sending out through our project out to actually be processed with the Ollama implementation locally. Beyond that, the flow works the exact same way and uses message history to store context for the rest of our conversation with the LLM itself. And then finally, we have our MCP tools. Now these tools allow us to query data particularly for each site. We have 3 sites in question, which is Funabashi, San Francisco, and Hanover. These queries basically select all of the records from our table where the site ID matches Funabashi, San Francisco, or Hanover, and then orders the responses by their SIM timestamp and limits the total amount of records to the maximum level of records that we might expect coming across the line. For instance, Funabashi only has 93 topics associated with it, so pulling 100 is reasonable for this particular implementation. From here, we can use MCP with Flowfuse Expert, and we can ask all sorts of questions. Now we're going to expand this over the next week or so, but you can already see that this is a much easier process to surface specific data. So as you can see, this opens up a ton of local as well as cloud interactivity. We can make all sorts of requests and get insight and information faster than ever before. Now we're not done iterating on this part of the build, there's still some more work to be done, and I'm really excited to get the final build in situ at Hannover Messe. We hope you liked this video. If you did, please consider giving us a like, comment, or subscribe. And if this piqued your interest in Flowfuse, head on over to flowfuse.com to start your free 14-day trial. This has been Christopher Sandoval, thanks for watching, and I'll see you next time.